Hello. Today we're doing section 1.4, which is entitled Experimental Design. We're going to look at two different types of studies. We have studies that are observations or observational studies, and we have experiments or experimental studies. In an observation or observational study, all you're doing is observing. You're watching and you're measuring characteristics of whatever you're studying, but you don't modify the subject being studied. That means you do not intervene at all. You're only observing. Okay? So I'm going to say here, don't intervene. Okay, that's going to be a key distinction. In an experiment, you do intervene. There is some sort of treatment that you're applying, and I have treatment in quotes because the treatment can be something like a medication, or the treatment can be something like being nice to someone or being mean to someone, or giving a group tutoring, or having a group read a certain study or read a particular book or follow a particular diet. So treatment doesn't have to be medication. The treatment can be something that you're intervening with the subjects in some way. You've probably seen experimental design before. Typically what happens is you have, that's not a very good circle. Let me fix that, that's gonna bug me. You have your control group. It's a little bit better. And your control group is not going to receive any treatment. So the control group receives no treatment. You're going to compare them to your treatment group. This is the group that gets the treatment. So when you're done, you're going to get data from this group and data from this group, and you're going to have a mathematical, statistical method to compare the results to see if there's a difference. And we'll do some examples so you'll see how this works. So the control group doesn't get any treatment. You notice here I also have that the control group gets the standard treatment. And in the medical field, one of the things that we don't want to do is, there's the saying, do no harm. If you want to check new treatments, you don't want to withhold treatment from someone. So you would give them, the control group would get the standard treatment, and the treatment group would get the new treatment. And you could think of this as your clinical trials. It's a common situation you've heard of, I'm sure. Okay. So the treatment group obviously gets the treatment. You're going to be comparing these two groups to try to see if there's a difference. Is the treatment successful? Is the treatment working? Okay. You're going to have some different variables in this situation. The explanatory variable is the treatment itself. So whether it's a medication, whether it's tutoring, whether it's reading a book, whatever it may be, the explanatory variable is whatever the treatment is. The response variable is what is affected or changed. And like I said, I'm going to do an example in just a minute, but what you might think about here, if your treatment is a medication, then the response variable would be the health of the person. Did they get better or not? The response to that treatment. Did it work? Did it not work? If it was a diet plan, did they lose weight or not? If it was tutoring, did their grade improve or not? Did they do better in the class or not? So the explanatory variable is the treatment itself. The response variable is the result of the treatment. And then there's something called a lurking variable. And the lurking variable is a variable that perhaps is impacting the results of your study or the response variable, but it's not directly what you're giving for your treatment. So it's something that might be kind of lurking in there that maybe you hadn't thought about when you set up your study. And again, my example coming up is going to address that. The experimental units are the people or things being studied. That's basically your sample. Who are you studying? Let me put sample in here. Now, as you know, we're using a new book, and our other book didn't get into this maybe quite as detailed as this book does. So moving forward, being able to distinguish is a study, an observation, or an experiment, and being able to see some of the issues, some of the conclusions, some of the things to watch for is what I'm looking for. Okay, so now we're going to do an example, and I'm going to do one that we can all relate to since we're all going to school right now. I'm going to study the effects of tutoring. So in this study, I'm going to have a control group, and this just, a lot of us are visual learners, so that helps us kind of see. There's my control group, and they're going to get no tutoring. And then I'm going to have my treatment group, and they're going to receive the tutoring. Okay. And when we set up this experiment, we would want to make sure that we had a random assignment to whether you're in the control group or the treatment group. Okay. So here, our treatment would be the tutoring. So we set up here the explanatory variable is the treatment. So we're going to say our explanatory variable which is the treatment, would be they get tutoring. Receipt of tutor or working with a tutor. The response, what happened? Did they do better? Did they do worse? Did they stay the same? The response variable, we would probably use their grade, and one issue with grades is grades are subjective. We could also have maybe their score on the final exam, something like that, to determine whether the tutoring was helpful. And again, you'll notice at this part in the course, we're not doing the number crunching. We're not looking at those grades, and we're not deciding, okay, did the tutoring help or not? Was the effect of tutoring a positive effect or not? We're just looking at the experimental design. Okay. So let's see, we did the explanatory variable. We did the response variable. The experimental units would be those students. The students in the study. So what you'll see on a lot of the problems on the online homework, they will ask you to define what is the explanatory variable, what is the response variable, who are or what are the experimental units. And oftentimes the experimental units are people, but they can be, if you were, you know, I'm trying to think of an example here. If you were checking the accuracy of a thermometer or something like that, then the thermometers that you were measuring would be your experimental units. Okay, so we're looking at this example and I'm using it to talk about these different terms. And the last thing I want to look at is this lurking variable. So in terms of this example, let's think about if there might be some lurking variables, some things that are impacting the grade that may not be tutoring. What are some other things that could impact this study? And if we were meeting live, we would have a little discussion about this. Some other issues that you might think about. Okay, attendance. That's going to affect grade. Homework. That's going to affect grade. What else? We might have just the fact that someone is sitting there with them might be making a difference, not the tutoring per se, but just the attention. Might be kind of a placebo effect. We'll talk about that in a second. Okay. So right now, being able to recognize, if we go back here, was this an observation or an experiment? We can see this was an experiment because we were intervening with the subjects. We had a treatment. If we were doing observation, we would just observe. We wouldn't intervene with the subjects at all. The control group was the group that got no tutoring. The treatment group was the group that received the treatment of tutoring. Explanatory variable is the treatment, which is the tutoring. The response variable is what they got. Did the tutoring work? Did their grade improve? And we also talked about the experimental units being the people, the students in the study. The lurking variables could be attendance and homework and other factors that impact the grade. The other thing could be, for this group, we're not providing tutoring for them, but maybe they're getting tutoring at home. Maybe they're getting help from somebody else. Maybe they're going to the math lab. So that could be a lurking variable as well. Okay, so we want to talk about these terms here: placebo, blinding, and what a double-blind experiment is. A placebo, most of you've heard of the placebo effect, is a treatment that cannot influence the response variable. In other words, a lot of times the placebo is like a sugar pill. See if I can fit it in there. It could be a treatment, or the person could think it's a treatment, but it doesn't have any active ingredient. So in their mind, they're taking a pill and it's making them better, but it really doesn't have any active ingredient. So the placebo effect can be a situation where you think you're getting better because of this medication when there's really nothing in there, okay? Another example of a placebo, sometimes you might see on TV, there's people taking, you know, Copperfit or a certain skin cream, and they talk about how their skin looks so better. Well, they want their skin to look better. So we don't know, is that treatment really helping, or are they just expecting it to help? Another example from the tutoring standpoint, we could do a study where maybe someone didn't tutor, didn't actually help the student, they just sat there with them. some people would do better or would think, oh, they're here helping me. And because they think they're helping them, they do better. So the placebo effect is when there might be something that the person involved in the study thinks is helping them. And so that makes the response like, oh, is your pain better? Yes. When really it isn't, it doesn't have anything to do with the treatment. Okay, blinding. In a blind experiment, the person that has designed the study doesn't know which group the people are in. So for example, our situation here with the tutoring, if I were the person giving the study and I were grading papers, I wouldn't want to know who's getting tutoring and who is not, because it might affect how I expect them to do, and that might at a subconscious level affect how I see things. So you can have a single blind experiment where maybe the participant doesn't know and the researcher does, or the researcher doesn't know and the participant does. And then in a double blind, neither the participant or the researcher knows who's in which group of the study. And an example here, my son, who is now, well, he's going to be 23, when he was a baby, he was getting his vaccinations, and they had a study going at Kaiser. And it was checking for the, I think it was the Prevnar vaccine before that was out. But what they did is they used a little stamp on his immunization record to track which group he was in. And at that time, Blue's Clues was popular. So they had this little like blue paw print that they put on his immunization record. And that was how they characterized. He was in the blue group. They didn't know which vaccine or which form of it he was receiving. And that was a way to keep the experiment more accurate from a double blind. We didn't know which one he was receiving, and the researchers didn't know. The study ended up being so successful, they stopped it early and started making the recommendation for infants to receive this, because it was so effective at helping. I think it was the Prevnar vaccine. So double blind, neither the participant or the researcher knows. Single blind, it's one knows and one doesn't. Okay, we're going to do another example, because really we have all these definitions, but what's important is that you know how to interpret and apply them. So again, you're not going to be tested on the definitions, but you're going to have to know, if I say, you know, what's the control group? What's the treatment group? Was this a single blind or double blind study? You're going to need to understand what those terms are. And this example, I typically do as a group in class. So I do want to give you some time to think about it. So as you're taking your notes, you may want to pause this, think a little bit about what your responses might be, and then start it back up so that you have time to kind of process it before you see what the results are. So this one is talking about elderberry, and it's been used for centuries to treat seasonal flu and colds. It appears to boost the immune system, and it has been shown to inhibit various influenza virus strains in lab experiments. Benefits have been found for a standardized elderberry extract syrup. So this would be more of a natural treatment for the flu and cold. So they did this study, consisted of 60 patients who had suffered from flu-like symptoms for 48 hours or less. They either took 15 milliliters, 1 tablespoon of the elderberry syrup, or a placebo. So some of them are getting the elderberry syrup, and some of them are getting some kind of sugar water, basically, something that has no active ingredient. So they think they're taking something, but it's really not doing anything. Those taking the elderberry reported that their symptoms were relieved about 4 days earlier than those on the placebo. Okay, now you might say, oh, they reported that. We would probably want to observe, and obviously I used this for a homework at one point. It doesn't have any points. Okay, so you may want to look at these questions, pause it, kind of think about what your responses are going to be. And then when you start back up, we'll discuss it. So the first thing I would do, it says, what is the population? And then it says, describe the sample. It's very common to see the population asked for first. I think it's easier to find the sample first. And the sample, again, is the group we studied. So if we look at this, it says one study consisted of 60 patients. So we actually studied those 60 patients. Now, if you write 60 patients, I see that you get who or what the sample is. Sometimes students write a little bit more, that's fine too. And this is where the gray area comes in that maybe you're not as used to in math. So 60 patients are fine. You could have also been more specific, 60 patients who suffered from flu-like symptoms for 48 hours or less. Okay, so this is basically right here, our sample. So they took those 60 patients and they divided them into 2 groups. The control group got the placebo and the treatment group got the elderberry syrup. Let's do the population now. When they did this study, let's get in the mind of the researcher. Why were they doing it? What group of people or what group in general are they hoping to be able to extend the results to? I'm going to start with the word all. And with the population, oftentimes there's a few different populations that I would accept as correct. So when I look at this, I want to study these patients to see if elderberry syrup helps with the flu. So who am I trying to help? People who might get the flu. So you could say all potential flu sufferers. Or you could just say all people, right? All people can get the flu. So either of those would be acceptable. And if it isn't verbatim, I would say start with the word all and just think about, okay, when we're done, who are we going to make this recommendation to? Well, everybody can get the flu, so all people would be fine. Part C, was it an experiment or observation? And sometimes you'll see experimental, an experimental study, or an experiment, an observation, or observational study. Did we intervene? Yeah, we intervened. We gave them elderberry syrup or a placebo. So it's definitely an experiment because we intervened. Now, sometimes students say, well, you intervened and then you observed whether they got better or not. There's always going to be observation. The difference is whether you intervened to try to change what was happening. Okay, explanatory variable, response variable, experimental units. Experimental units is easy. Experimental units, who did they study? This would be the people in the study. Okay. Explanatory variable, remember, that is the treatment. That's the thing you're checking. Does this make a difference? Does this affect things? Does this make a change of some sort? So the treatment was the elderberry syrup. The response variable would be, okay, did they get better or not? You gave them this elderberry syrup. Did it make a difference? So here I would say whether their symptoms were relieved. So I'll say here relief of symptoms, but you can phrase that in lots of different ways. Like we're checking for that. We could say, you know, did they get better? We could say health. So the response variable is the result of taking that elderberry syrup. Did they get better or not? Did it work or not? Did it help relieve their symptoms? And then if we look at this, it says what conclusion was reached? Well, it says right here, those taking the elderberry reported that their symptoms were relieved 4 days earlier. You can write that whole thing. Sometimes there's more comfort for students writing the whole thing. Or you could say symptoms were relieved. You could say it worked. Again, there's a lot of different ways to communicate that. The whole point of the study was, is the elderberry syrup working? It looks like it is. Okay. I didn't ask if there were any confounding variables or lurking variables. Some considerations might be, were they taking anything else? Were they doing things like getting more rest, having chicken soup? You know, we don't know what else they were doing. So that might be some confounding variables for this study. Okay. A problem like this would be very typical to see on a test, because I can give you one example and then I can ask several things for that one example to make sure you understand the material. Okay, just at the very end here, these are 3 types of studies based on time. So a retrospective study is looking back in the past. And what I might think about here, let's say I was looking at a prior semester and I was looking at students' grades or the success of students in my class. And the college does this. They go back and they look, you know, what percent of students passed a class, what percent of students failed a class, and they use that as a gauge for, is our program working, okay? So this is looking back at something that already happened. A prospective study is looking forward. So that would be, let's say I wanted to study our class this semester. I would start now and I would project forward. And then a cross-sectional study, it just is at one point in time. So this could be something like I could ask you a question for today only, like, you know, how many hours of sleep did you get? Or, you know, what if I took everybody's temperature and we got that right now? It's not going forward beyond today. We're just using the data for today. So there is probably a little bit with retrospective, prospective, and cross-sectional on your online homework. Okay, so section 1.4, go back up to the top here, and this is called experimental design. You're all set. You can work on your online homework and then move forward to your paper homework. Have a nice rest of your day.